Greetings, everybody. Michiel, or MH here, and I worked with Tsepang on this project. And it was all about seeing how we can leverage satellite or other images of solar panels towards identifying them firstly, and then being able to increasingly count them and kind of get a sense of the density of solar panels within regions in South Africa. Can go to the next slide. A bit around the motivation for this. So I suppose the majority of us have been experiencing the challenges with power production in South Africa. We know the realities of load shedding, and hopefully renewable energy sources can play a positive role in helping us be more sustainable in our energy reproduction or production going forward. And as I mentioned, we kind of used computer vision together with the satellite images and other images that we managed to get our hands on towards being able to specifically look at the Tshwane area and gauge the number and density of solar panels. Going into the next slide, I'll quickly run you through our approach. So we were very fortunate in that we received labeled images that also had masks with exactly where the solar panels were on the images. We went through a process of cropping them to see how that works in terms of modeling. Then when we struggled a bit with the resolution and quality, we went back to aerial images with higher resolution taken from an aircraft. There, unfortunately, we didn't have the masks, so also didn't win there. And then last 2 points, we went into the process of object recognition. So firstly, looking at crowds of solar panels, and then finally, looking at specific solar panel placements within an image and building a model to identify those. Then on to the next slide, just quickly our results. So ultimately we managed to identify about 40 to 50% of the solar panels. Still a bit of false positives, so still room for improvement. Over to you, Tsepang.
Okay, so with the deployment, the goal quite simply is to determine, again, what the density of solar panels are in the municipality. The density should give us a sense of which particular areas within Tshwane have the most solar panels, and from that we can estimate how much electricity can be produced off of solar energy. So the best way to communicate this, we found, would be an interactive map showing a summary of how many panels were detected and in which particular locations. So we designed the following Streamlit app where the user is able to firstly change the style of the map, and they can also filter on a particular area. They can adjust the sizes of the different features on the map, and also are able to see the details on the number of detections and potential energy produced by those number of solar panels. So this will enable the municipality to zoom into those particular wards or locations and provide incentives to those who are embracing renewable energy. They can also support the communities that cannot afford to have such resources. And a time will also come along where large solar battery storage systems become essential. And having such insight will enable them to determine where best to build such facilities. The table on the left is just showing the top 10 detections we found in the Pretoria Old East area. You can see Hatfield is number 1, followed by Arcadia, Pretoria Central, and then you also have Sunnyside and Groenkloof as well. Then on the right, the model is able to detect the actual solar panels and the level of certainty that it is actually a solar panel. So on the left, the orange one says 79%, and the one on the right says 73%. So thank you.